Various models and maps of the flat Earth have been proposed. One of the talking points of the flat Earth is about the general distribution of the continents. Here we see images of some geographic models of the flat Earth, which convey the different concepts of Antarctica within this theory. Antarctica is the known edge continent surrounding the Earth. But all these maps coincide, they are very similar. Many opponents of the flat Earth model mention that the flight time from Sydney, Australia to Santiago de Chile, it would be a convincing proof of the spherical Earth. According to official figures, the distance between these two cities is 11,340 kilometers. But how did they come to that conclusion? Measuring the distance by land is practically impossible. In 1529 Diego Ribeiro, a Portuguese under the order of the King of Spain, created the first scientific map using writings and designing perfect latitudes. Other maps were derived from that. We have been told that the Earth is spherical or geoid, and to represent it is necessary to use a system of projections to go from spherical to plane. This is not something simple, since not only the surfaces must be represented, but also the angles, information and other elements. Today these cartographic representations are made by computer using geomatics. Geomatics is a discipline that encompasses geosciences, such as cartography, geodesy and topography, with the integration and application of information and communication technologies. This discipline makes it possible to capture, process, analyze and model to form the maps and images of the Earth's surface. With aerial photography techniques that use drones and airplanes that scan the territory to create a digital model and represent the plane. Today we know that satellites are not as they tell us, and they have another flight system. The cartographies that we know throughout life have great errors in the distribution of continents, the sizes, directions and the distances between them. But those are the maps that we see in books and that have remained in the collective imagination and with the false perception of our world. The maps do not show the actual sizes of countries or continents. The classic cartographic representation that we see in school is not a true reflection of reality. Some show Europe larger than it really is, or the United States much largest, Africa and the smaller Latin American countries or Greenland. 2 million square kilometer, the size of Africa, 30 million square kilometer, that is, it is 14 times larger. Alaska appears almost the same size as Brazil, when the area of Brazil is almost 5 times larger than Alaska. The Mercator projection is widely used in navigation, but analysts mention that it is not adequate to represent our world completely due to the distortion of the different areas. When this projection was invented, it allowed loxodromic trajectories to be traced. A straight line on the map is equivalent to a constant course in navigation. Perfect for boaters. The big drawback is that the distortion of the areas is immense, and it is greater the further away from Ecuador the territory is. That creates big glaring visual errors, like the ones mentioned above. One way to avoid this is to use another type of projection, such as the Winkel triple or the mile-wide, much more precise in relation to the surface in the different parts of the plane. Another option is to compare different territories by superimposing them on the same map. Gerardus Mercator himself used an equivalent projection that preserves the proportion between areas in his regional non-navigational maps. As a result of criticism of Mercator's projection, modern atlases no longer use it for world maps or regions far from the equator. Adopting other cylindrical projections or equivalent, equiarean, projections Arno Peters generated controversy when he proposed the projection known as the projection of Gull-Peters, a slight modification of the cylindrical Lambert equivalent, as the alternative to Mercator's. A 1989 ruling by 7 North American geographic groups ruled out the use of all rectangular, cylindrical, coordinate world maps, including Mercator and Gull-Peters. Take the case of Africa. With its 30 million square kilometers, it is roughly 3 times Europe, including Russia west of the Urals. To get an idea of the true size of the continent, it is enough to compare it with other countries and regions of the world. In addition to the errors mentioned above, current maps also have errors related to the digitization process, such as absolute altimetric error of the map or maximum error allowed in photogrammetric processes, propagation of planimetric error to altimetry, dimensional deformations of the map, due to alterations in temperature and humidity. In almost all countries, a large part of the large-scale mapping has been generated by a wide variety of agencies or companies with unknown quality parameters. If the Earth were a ball, there are several flights in the southern hemisphere that would have a faster and straighter path over the Antarctic continent. According to the Federal Aviation Association, USA, no air flights have traveled much shorter routes over the Arctic and Antarctica due to the cold weather that affects the flights. It's funny because NASA claims to have technology to stay in condition much more cold or hot than those supported on Earth. Of course that is an excuse, since flights over Antarctica are not made because they are impossible. If it could be confirmed that there are flights that take this route over the South Pole, it would prove that the Earth is indeed a balloon. So we can conclude that there are a large number of errors in all known types of maps. Some areas with strong relief may have a maximum error tripled. Why can't we 100% trust the equidistant azimuth projection map? Because in this map, commonly used in the flat Earth model, the distortion of areas and angles grows the further from the center of the map they are. This projection distorts relative areas and distorts shapes and angles. Therefore, the proportions and distances that are seen are not correct and it is not an exact representation. Although it does serve to illustrate the model of the flat Earth. To be able to understand it and give us an idea of what the world where we live is like. It is the closest to reality, according to research on this topic, but the exact size and proportions are still unknown. Many times we trust without doubting the images that the maps teach us without taking into account everything related to errors, distances, size, proportions and other problems mentioned in this video. For this reason you cannot try to discredit the flat Earth model by a simple map and a flight.